Hello everyone. In this short video, we'll quickly go over some of the features of the mathematics syntax of LaTeX. So in our previous video, we made this very basic showcase, and today we will focus on the mathematics portion. So in the previous video, we've learned that there is line mode and display mode, right? So line mode is like this, where it's a part of a paragraph, and display mode is where it's in the center, and you can also put numbers by them to refer to them. So some cool features of math mode is Greek letters, right? So before I show you the Greek letters, I just wanted to show off my setup here. This right here is my NeoVim configuration of snippets for LaTeX. So I have pretty much just all the Greek letters up here, and then I have some just really basic syntax, the stuff that I use all the time. So like infinity, square roots, fractions, integrals, and some stuff for uh, just ease of typing. So like with if I type parentheses, uh, I want the cursor to jump in the middle of the parentheses, and yeah, so that's how I type, how I increase my typing speed. Okay, so in math mode, of course, you can have Greek letters. So with my uh, shortcuts, right, like pi, I can do capital pi, uh, epsilon, alpha, beta, you name it. I probably have it set up. So if we write this, um, yeah, Greek symbols, that's very useful. Some other useful symbols that you might want to use are times. There's also C dot, div. I rarely use div. There's not equal, less than equal, and greater than equal. And there's also plus minus. Those are some of the common ones that I personally use. So we have times, which is this cross, and then dot, C dot, which is this dot, right? So if you're doing uh, like linear algebra, for example, cross product and dot product are very different, and that's how you would show them. Divide, I don't really use it, but like not equal, greater than, and less than or equal to, and plus minus are really common symbols. And then for equals, you just type equals, greater than, less than, right? So simple stuff. Yeah, those are pretty much all the common symbols I use. Okay, next we're going to go over trig functions. So if you try to type, say, sine theta, right, you can see that LaTeX treats your sine here as three variables, right? So it kind of looks like, because it's in cursive, you have the variable s, the variable I, and the variable n. So with trig functions, the nice thing is if we just type a forward slash before them, it'll turn into like just normal letters. That's very useful. All right, so we can, and I think the hyperbolics are also in here. So if I type like cosh, it should also display as normally, yeah, cosh. Uh, yeah, so that's useful. And if you want another function, but you want it to look like basic text, you can use text, right? So if we want to say like projection, right? So then we can do projections, for example. And this moves nicely into our, so projections, right? You have like a subscript. So let's say we want a projection of U onto V, for example. Right, so we can write that. The subscript is just underscore. And if we want to say like U squared, to show this off, yeah, and the superscript is the shift 6, whatever this is, the little hat symbol. So that's how you do subscripts and superscripts. This only works, uh, you see, if, make a new line here. This only works if you have a single letter, right? So for example, if I try to type e to the 2x, right, just like this, it will give us e to the 2 times x, right? Because it only reads the first symbol right after your superscript. So if you want to type many things, you just put the superscript in brackets. So if we do 2x like this, in curly brackets, it will actually give us e to the 2x. And same thing with subscripts. Okay, next we will go over how to do fractions. So fractions is just \frac. You want to put two curly brackets, and the first one is for whatever's on top, and the second one is for whatever's on bottom. So we can say a over b. So yeah, a over b, and with square root, it's just sqrt. So plus square root of x, let's say. Uh, oh, there you go. Accidentally deleted one of the backslashes there. Okay, yeah. So square root is like this, and if you want a square root that's more than square, if you want like the third root or whatever, you just put square brackets with whatever number. So I can have like the 69th root of x. Nice. Oh, and another thing is if we attempt to put brackets around this, you can see that the brackets are kind of small and they don't span the entire fraction. Right? So the way we can change this is we can say left, and over here we say right. And then this just tells LaTeX, hey, this is the leftmost bound and the rightmost bound of these brackets. So make these brackets the size of their environment. You can also manually adjust this with using \big, but I rarely use it. Left to right works really, really well. Okay, so next we'll go over some calculus. So if we want to do integrals. Oh, for calculus, first of all, d by dx can be written like this, right? And if you want to do partial derivatives, it's here, we'll put a space here. It's just partial this, partial by partial x, like this. Then you get the nice partial. So that's cool. With integrals, it's it's this one here, \int, and then you can have a subscript and superscript on the integral. So we can say integral from 0 to pi of sine of theta d theta. Just like that, right? Integral 0 to pi sine theta d theta. And if we don't want if we want no bounds on it, we can just do this, the indefinite integral rather than the definite one. We can just remove the subscript and superscript, and that's that. And then limits. So limit is just \lim, and then you put a superscript, so we can say from n \2 infinity of 1 over n equals 0. Right, so limit as n approaches infinity of 1 over n equals 0. So that's how you would type something like that. Then with sigma notation, it's backslash sum. So then we want to say the sum of n equals 1 to infinity of 1 over n squared, for example. So that will give us, that's how you write sigma notation, backslash sum. And yeah, so that covers all the calculus I've learned so far, but I'm sure there's more. And then with linear algebra, right, sometimes you want to write matrices and whatnot. So it's an environment, begin end matrix, and it works exactly like a table. So if we want to do 1 and 5 and 0, here we'll just do a 2 by 2 one. 2 and 9. There you go. And oh, the matrix needs to be in a math environment as well. So if we just do this, that should fix it. Yeah, so there is our matrix right here, and that looks kind of out of the blue, right? It's just an array. There's no brackets next to it, so we can actually put B matrix. Oh, whoops, that's the wrong one. It's up here. If we put B matrix, this puts brackets around it, so it looks like a proper matrix, right? So if we, for example, want to find the determinant, we can say text det, and this equals 9 plus 10 equals 19, right? So there you go. The determinant of this matrix is 1. Oh, that's minus. I am an idiot. Minus -1. There you go. There you go. Yeah, so 9 minus 10 equals -1. And yeah, I mean, that's pretty much the basics. I mean, it's all the mathematics I used, and with this, you have quite a bit at your disposal. So this year, in my first year University of Engineering, for example, I have made it a challenge for myself to write all my math homework, calculus and linear algebra, in LaTeX to hand in. So this is an example of one of my homework, right? So this looks like some wacky function, and we needed to find the arc length of it. So like, with some practice and patience, you can, yeah, make some fantastic equations. Setting up these snippets will really help with your typing speed, as you can see, and I will probably do a separate video on it. But it's quite specific to whatever text editor you're using, so it's going to be a while before I do it. And if you're a math major who needs way more wacky symbols than I do, you can always check out the Wikibooks LaTeX mathematics page. This is a fantastic page with a bunch of math notations and everything you can possibly need, especially at the bottom here, where you see all the Greek letters. You have a bunch of wacky symbols. I have no clue what this means. What is this funny plus sign with a circle over here, right? And everything I showcased here is here, like plus, minus, times, divide. But yeah, there's a ton of symbols that you will ever need. And yeah, that should do it for this video. See you next time.